Hey, we're just going to revisit the cargo bay after a bit of a hiatus of non-seasonal flu, which I'm recovering from now. We've got electrical stuff to do, preparing for the aluminium cladding that's going into the back of the cargo bay. So we're going to start by disconnecting everything and removing it from the wall safely. And that means that everything that's been put there has to come off and clean up all of the spray foam and everything that's been left on there from the original construction and move the batteries out of the way, which are not light. Luckily, when I started doing this, I put plenty of length on all of the cables so that this can be done. So this spray foam is literally everywhere on the bus. It was used to seal in all of the original aircon piping system which went through it. It's not difficult to remove once you get the technique, but it's just time consuming and it never comes off in one piece like I'm showing there. This is a 1.5mm thick aluminium checker plate or diamond plate. It's nice and hard wearing, and this single sheet, once it's cut to shape, should fit nicely in the space in the back and allow everything else to be put back into place. And after a bit of a struggle and adjustment, it did seem to fit quite nicely. So from this point, it's just removing it again and adding the glue. I don't know what glue would have been best for this, but from what I could find, this stuff seemed to do the job. It definitely smells like it should do the job. It's Evo Stick 528, if it means anything to anyone. It seems to have worked. I mean, it's not coming off again. It was quite a cold day that this was going on as well, so it's a lot thicker than I think it would normally be. I'll save myself the embarrassment of watching me trying to get it back into place with all of that glue everywhere. But once it was in, now all of the boxes can be remounted into their final position. All of the screws for this are going in through about 3 sheets of aluminium that are making up the back end of the bus. There's nothing the other side of this other than a firewall and another sheet of aluminium, which clads the other side. There's no pipes, no electrical cables, and very little steel framing that's actually going through it, so these screws are fine where they are. And because all of the cables were left a lot longer than they needed to be, I had the opportunity now to route everything into the right place, cut all the cables down to the right length, and properly affix them to the back of the wall. Now we're doing the solar first just to get it out of the way, because the top end of that breaker, just above where I've got the screwdriver, is live with a couple of 100 volts, so it's better to keep that isolated as soon as possible.
is like, what is it like? What is it like? Went to California, or San Francisco, or walking around San Francisco. That's what we talk to the sex change surgeon. Talk to parents all the time that are terrified of this. They're terrified of the day when their daughter comes home and says, "I'm a boy." You know, we just decided.
There's the bus bars, which are taking both of the battery packs and commoning them in the box. And then this is the main AC power that's going to the AC breaker board. And skipping ahead a little bit, unfortunately not all of the cables were as long as I would have liked, so I have to wait for some 25mm square section to reroute all of these cables for the inverter's main power. But they all hook up back into their original spaces. They're just not quite as neat as they will be eventually.
Let's see. So we should be able to power this on. Inverter on. The solar's on. It's putting 8 amps into the battery, which is nice. 161 volts, 3.5 amps, 560 odd watts. So what have we got? Well, we start with the storage, which are basically the battery packs which you've seen me build before, which need their protective cover on because of all of that reason. These are 48 volt packs, which actually probably sit normally at around 50 volts, between 50 and 55. They are comprised of 16 3.2 volt lithium iron phosphate cells that are 280 amp hour each. So for the whole pack, that's 48 volt nominal. So on the positive side, we've got the battery isolator, a 400 amp fuse, and then the Anderson connector, which is used to connect and disconnect the whole pack. And then on the negative side is the JKBMS, which you've seen me modify for fitting on top of this pack in the nice solid configuration that we've got it. There's 2 of those. They're identical. Same breaker, same fuse, same Anderson connector. These are all then commoned inside here, which has got 2 massive copper bus bars, plus a negative. On the negative side, both batteries are commoned through a Victron SmartShunt, which has got this serial connector connected to this Esp32 Power over Ethernet microcontroller, which logs all of the data from the SmartShunt into Homeassistant. After that, it goes into the DC breaker box, which has all of the DC circuits from the 150 amp double pole breaker that goes straight to the inverter, and then the rest of the circuits around the bus, which are all the DC combination of 32 and 20 amp breakers. I'm sure I had more of these at a lower rating somewhere. I'll have to find where they've gone. The 25mm square section goes into the inverter. The inverter is then through this isolator, which I'll turn back on now. The purpose of this is that if we decide to go the route of having 2 paralleled inverters of a probably slightly smaller setting than this, they can be common together inside this box and isolated from each other independently. After that, it goes through a massive, I think it's 8mm cables, which then go into the main AC breaker box. And then nothing's labeled yet, but these are UK standard split load, which has RCDs protecting 2 halves of the circuits. Obviously the solar comes in from the roof, diversified one side and the other, and then into two separate double pole breakers, which then feed into the solar charge controller part of the inverter. The DC side of the electrical system, there's a dedicated line that goes right to the front of the bus for the server rack and all of the comms equipment. That's on its own breaker and its own dedicated cabling. But the 24 and 48 volt circuits which go around the rest of the bus are between all of these breakers. So obviously there's a 48 volt circuit that goes on some 6mm cable around the top floor, and the same for the 24 volt. So the 24 volt circuits all come off Meanwhile DC to DC converter down here. But that is about it. The only thing that's left to do now is find somewhere to mount this.
And this is the that my past self was alluding to. I designed a case in Fusion 360 for the TTGO POE ESP32 microcontroller, which is a bit of a mouthful. It's designed for use with brass inserts so that you can screw it nice and securely into the case. Here's a little time lapse of it being printed. The BME 280 temperature sensor fits nicely in the lid of the case, and then once it's all connected and the firmware flashed, which is based on ESP Home, I'll have to set up a GitHub for all the code for this, but the 3D model will be in the description.
Don't really know where it would go other than there. So I guess that's where it's going to live. I've got a little bit of DIN rail, and I think that would fit nicely just by there. Cool. Let's get the drill. So I've got these nice tech screws. I've used them on all of these boxes. Everything is mounted to the back wall with this. Nice. Well, that's going nowhere. And it's all made so much easier by the fact that this is powered over Ethernet. This will be monitoring everything else that's going on in the cargo bay, including the water levels for the 3 tanks that'll be here. And it's also doing temperature and humidity inside. As I said, the data from that is all going into Homeassistant, which if we look at here, yep, already connected and sending data. Tells us the current battery power, battery storage, based on obviously the estimate of the SmartShunt. And the temperature sensor is reading correctly. Currently putting 6 amps from the solar in. Cool. Looking good. Well, at least now all this is sorted down here. We can get on with the important stuff. But yeah, for now, that is about it.